Hello everyone, today we will try to teach neural network to play car racing game by OpenAI. Now you see me playing it. The generated track is random for every episode. You can see some indicators at the bottom of the window, from left to right, true speed, 4 absolute sensors, steering wheel position and a gyroscope. There are 5 actions: do nothing, steer left or right, accelerate and brake. The reward is given for every track tile visited, and decreased a little for every step, because we want our networks to be as fast as they can. Remember, it's a powerful rear-wheel drive car. Don't press accelerator and turn at the same time, especially on the grass. The episode finishes after 500 steps, or the car is far off the track. After 10 tries, I got score for about 350 on average. Let's find out if we can learn neural network to play better. But how our network will look like? As input to our network we will have a picture, but we will not pass RGB components. Instead we will activate only neurons that correspond to a track area. Our picture is 96 by 96 pixels, so our networks will have about 9000 input neurons. We have only 5 actions, so our networks will have 5 output neurons. In the middle we will create a random number of neurons, randomly placed and connected with each other. For learning, we will be using a method called NEAT that was explained in the first video. Okay, let's start learning. After a first day of learning, the best network played like this. As you can see, passing corners is not very good, and it easily loses the track if it's not right in front of the car. It got score for about 90 on average. After a week of learning, the best network played like this. A little bit better, but it don't use the brakes at all, and still loses the track easily. It got score for about 150 on average. Probably network is too complicated and will take too much time to learn it on my PC until it reaches my level of playing this game. Is there something we can try to speed up learning? Actually, there is something, and it is called Samplification. The main idea of this principle is to divide our picture to the same parts and to fill them with the most popular color inside it. Let's see how the picture changes if we simplify it with different sample sizes. As you can see, with increasing sample size we lose more and more information, and with this sample size the game looks completely unplayable. So what is the benefit of simplification? For example, for this sample size the picture still looks good, but the network will have 64 times less input neurons than the original one, and theoretically it will take 64 times less time to learn. But which sample size should we choose? Let's find it out and learn each one from scratch for a day. And here are the results. As expected, for small samples networks were too complicated and it wasn't enough time for them to learn, and for huge ones the game wasn't playable and they couldn't reach any significant results. So I continued learning for a week for this sample size, and here you see the results. As you can see, it is much faster and loses track rarely. After 5 episodes it had score for about 600 on average. Mine was 350. If you like the video, press the like button and subscribe if you don't want to miss next ones. Thanks for watching.